All right, so 4.3, these markers are not working. 4.3, solve x squared plus bx plus c equals 0 by factoring. Okay, notice these are going to be the easy ones. There's nothing out front here. It's just a 1 there, so these are the easiest type of factoring, which you should recognize all of the types that we're going to look at from Algebra 1. But this is kind of a refresher / maybe getting a little bit more, I guess, in-depth with them. It would have been near the end of Algebra 1, so hopefully you kind of remember those. But just to get a few definitions here that are important. A monomial is an expression that is a number, a variable, or a product of a number and one or more variables. Okay, so something like x squared or 3x or 4. Okay, those are monomials. Okay, a binomial is the sum, okay, or difference, as the case may be, of two monomials. So something like x plus 4. And then a trinomial is the sum, okay, or difference of 3 monomials. So something like 2x squared plus 3x plus 1. Okay, something like that would be an example. Alright, so essentially with these, we're going the opposite direction of foiling. So that's what we're doing, and we're going to also get two special types here with these as well. I will tell you that the way the book kind of introduces these examples of just factoring in general is to make a table and then add up their values. I think that's really a more difficult way to do it. That is not like my first recommendation of the way to do those problems. I think it's easier to almost do like a factor tree or something other than a table when doing it. So we'll look at a little bit of that and then some of the special products. So simply factoring something like x squared, different color. Almost a different color. X squared minus 9x plus 20. Okay? Basically with these, I'm just going to do like one example here and we'll do more examples later. But basically with this, you're going to split this into its factors, and you need stuff that when multiplied by 1, okay, when I'm just saying this so that when you have something in front of x that's not a 1, okay, basically you're going to take those two factors, you're going to figure out what combination of those numbers adds together to give you negative 9, okay, or subtracts. So I have 20, okay, so I can break 20 into 2 and 10. 10 can go into 2 and 5. So now I can look at my factor tree and I can come up with different combos. So I can have 2 times 2, which is 4, times 5, which was, let's see, 4 plus 5 would be 9. So that would work. 2 and 10. Well, 2 and 10 obviously equal 20, but when added together don't give me negative 9. So I'm going to use the option of 4 and 5. Now, this is negative, but this is positive, so both of these are going to be negative numbers. So I'm going to get x minus 4x well, minus 5x plus 20. I usually don't write this step, and I can explain to you why. Basically, I save a step here when I have these simple ones like this. So I'll show this step here, but if you want to skip this particular step and go to the step that I'm going to show you in a minute, you can. I'll show you where you would have to, or what you would have to write here. But basically here you can pull out an x, so you'd be left with wait a minute. Yeah, hold on. I never do it this way. Scratch this. Don't write it this way. It's just easier to not. Okay? I know I have a 4 and I have a 5. Those things do this. So basically all you do is you write x minus 4 times x minus 5, and you're done. Okay, so with these simple ones, you can just write it this way, and you're done. This method, oh, well, I know what my problem was. I didn't have the squared written there. I still just ignore this method. I can show it in class if you want to see that step, but with ones like this, you literally just x minus, and then whatever the numbers were that you chose, go here. Okay, when we get to the more complicated ones, we'll do this step here that I just missed putting a squared on, and that was the problem. Sorry about that. Alright, anyways, we'll do those when we get to class. Also, just know there are some things that can't be factored in this traditional way, and we'll get a method later on for how to solve those. Maybe you have an idea of what that would be if you remember from Algebra 1, but we'll learn that specifically later in this class. So for this time being, if you have something that doesn't factor into something else like this, like if 20 had not given me factors that would add up to -9, I would have just said no factors. So, but I do have some special factoring patterns here that we need to talk about. So, essentially these ones, we have two types, okay? And you will need to know how to go straight from seeing it to writing the formula without adding a bunch of extra steps. Okay, I will expect you to know that, hey, this is a difference of squares, or this is a perfect square trinomial. So there's the two names of them, but I'll write them down here for you. So a difference of squares okay, you basically start with something that is a squared minus b squared. Okay, and there has to be a minus sign here. This doesn't work otherwise. So a squared minus b squared. So this basically factors into a plus b, a minus b. Okay? Now, I could do stuff and actually prove to you that that is true, but just know that that is what you need to be able to get from point A to point B. No pun intended. Okay? So when you see a squared minus b squared, you go straight to a plus b, a minus b. Okay? Now, just a quick example. X squared minus 4. Okay? Now remember, 4 could be written as 2 squared. So I would do x plus 2, x minus 2. Alright, and then the other type is a perfect square trinomial, and in this one we have two options. So perfect square trinomial, you start out with a squared plus 2ab plus b squared, and that factors into a plus b squared. You start out with a squared minus 2ab plus b squared. This factors into a minus b squared. Okay? Now, just a note here, warning, note, something, reminder. Make this something really bold that you're not going to miss it, you're not going to forget about it. Probably should use a color I haven't been writing in. there is never an excuse to get factoring wrong. You can always refoil it, okay, to check it. Always foil to check your signs and factors to see that it's right. Okay? Never an excuse to get factoring wrong. Okay? A matter of fact, on some of the quizzes and tests, a couple of the problems, I may even put, if you check this problem, you get 1 point extra credit. Okay? There may be some of them that I say you have to check it. Okay? But this is going to be a little, well, you have to type in on Google Classroom, this part right here in orange. Okay, is your code. There. Okay, code words. So, there's never an excuse to get factoring wrong. Okay, we always foil to check it and ensure that it is correct. Okay, I have a lot of kids who tend to get signs wrong on them just because they didn't check it and they didn't realize that their signs were wrong and thus made their problem completely wrong. Okay, so make sure you always check it.